Auzubillahiminash-shaytanir-rajim. Bismillahir-Rahmanir-Rahim. In the name of Allah, who is the most merciful and the most beneficial. Today, I Shiva passes here in order to perform a small lab on Quartus 264 bits. In this lab, we have to perform almost 7 to 8 tasks, which are already mentioned over here in our lab manual. So this is the first code which is of arithmetic operations. So we are going to perform this very task in Quartus 2. So for that, we are going to create our new program. From here, we have to select the file where we want to save our task. As in desktop, I have already created task 1 name file. I have selected this file. Here, I will enter the name lab5-1. This is my first lab. So I'm going to put its name and move towards next. Keep it in deposit next. From here, we have to select log STL and then keep on next and then finish the task. Now it is creating our new file for running. It will take little bit time. From here, we will go for new file. From here, we have to select Verilog STL file and click on OK. As code is already mentioned over here, so I just copy the code and put it here, and I will just change the name of the lab task. As I already mentioned, lab 5-1. This is our lab's name, and remaining thing remains same. So I will just simply run the code and see outputs. So save the file. Now it will take a little bit time to get completed. Although it is a little bit slow software as compared to other softwares like C++ and other softwares, but it will take little bit time, not that much, but much slower than other softwares. As it can be seen that analysis is completed. No, it is just compiling the design. That is almost 20% done. As it can be seen over here that our compilation is done. Now we will move toward our next step. First of all, we will see our diagram locates in RDL viewer. It will and then it will generally show our circuit. As it can be seen over here that this is our circuit where two physical inputs are there, and here almost 1, 2, 3, 4, and 5 arithmetic operations are performed, and we will get the output from all these arithmetic operation circuits. Now we will move toward our second thing, that is our waveform. For that, we have to select Unity program VWF and click on OK. From here, we have to insert the node bus, and from here we have to new node finder, and then we have to list and then transform it to the next and click on OK, and then click on OK. These are the inputs and outputs nodes. From here, to get waveform, we will select the first one, and then from timer we will change its periods from 10 to 50. In the same way we will do with all from 50 to 100. In the third one, from 100 to 150. In the third one, 150 to 200. The fourth one, 250. Fifth one, 300. And in the last one, 350. As we can see over here that these are our waveforms. So we get the waveform as well as the circuit. So our compilation is done and the work on this very small task is also done. Now we will move to our next task. Uh, I will show the next task along with explanation, and remaining all the tasks were shown in just simply pictures form, as it will take a little bit extra time as all the compilation process is similar for all the tasks. So I will just run one more and then end the task. Thank you so much. Now we will move to our second task. The second task is mentioned over here, logic operations. Key symbols are n or n not symbol. So we will do the second task. For that we will create the new program. We will locate its position. Desktop, first task. Next. Here we will put the name lab 5 dash 2. Second task as it is mentioned. Next, next, next. And next from here we have to just select the very low HTML file. We will move to it next and then finish the task. Yes, process is totally similar. We will go to new. From here we have select very low HTML file and click on OK. We will just copy the code from here as it is also mentioned over here. We will just copy the code up to here and then paste it here. As we can see, our name of file is different from code, so we will put its name lab 5 dash 2, and then we will see if nothing is left. So we will just run our code and outputs and save it. It will take a little bit time for the compilation as well as analysis process, and then we will find our waveform as well as our diagram. As it can be seen over here that our analysis is done, no only compiling design. So it will take a little bit time for compilation. Almost all our compilation is done. Yes, we can see over here that our compilation is done. Now, for our diagram, we will go to the locate node and then locate in RTL viewer. After some processing, it will create our code. This is our circuit where 3 inputs are there and almost 9 gates are used. By using all these 9 gates, we are going to perform different logical operations as which are mentioned in this explanation as well as in this code. Now we will move towards our second thing, that is our waveform. So for that we will go on new, we will click on university program BWF and click on OK. From here we have to insert node, and from here node finder and then list, and then transform it here and then click on OK and then click on here. Waveform is not clear. To get a clear waveform, we will change its period from timer as We will change it from 10 to 50. The second one, we will change it from 50 to 100. In the same way, we will change it from 100 to 150. In the fourth one, we will change the way of the use from 150 to 200. And in the fourth, 200 to 250. In the fifth, 250 to 300. In the sixth option, 300 to 350. And in the fourth one, 350 to 400. So these are our waveforms of our logical operations. So our second compilation is also done. Though in the remaining task, I am just going to show the code, waveform, and the diagram of remaining task of lab. These are 11 tasks of this lab 5, from where I have present 2 with explanation. No remaining tasks, I am just going to show the code as well as diagram and the waveform of the other task. As this is third task and this is the code for it, which is already mentioned in our lab manual. And after the compilation process, this is our diagram and this is our waveform for the task. Now we will move for the fourth task. As it can be seen from here that this is the code for the fourth task, which is already mentioned in our lab. And this is the circuit where we have put 4 inputs over here, and here all the logic operations are performed over here. And this is our waveform for the fourth task. Now we will move back and then task number 5 here is the code, and this is the waveform where we have put 6 inputs in this and we get the output, 2 outputs basically. And then this is our waveform. This is our 6th code. This is the code. This is the logic diagram where we have put 3 inputs and get 1, 2, 3, 4, 5 outputs from here. And this is the waveform for the code. Now we will back, and this is our 7th task, and this is our code for the 7th task. Here is the circuit diagram where 3 inputs are mentioned and get the 3 outputs. And then this is our waveform. So we will move back. This is our 8th task, and this is the code for the 8th task. As it is already mentioned in our lab manual, we have to just copy the code from here and compile it in Quartus 2. And this is the circuit where we have put 1 input and get 2 outputs. And this is our waveform. Now we will move towards our 9th task. This is our code for the 9th task as it is mentioned. And this is the diagram where we have 3 inputs and get 2 outputs from it. And this is our waveform for the task. And we will move back. Task 10. This is the code for task 10, which is mentioned in our lab. And here only 1 input and get the output. And this is the waveform for the same task. And we will move towards our last task, that is 11th task. And the code for this 11th task is mentioned over here. Now we will see we have two inputs over here and get two outputs from the task. And this is the output waveform. Thank you so much, sir.